Hello class. In this video, we're going to focus on how to add and subtract mixed numbers. But before we do that, I want you to write in your notebook your complete heading, your first and last name, mathematics, the date, your period number, and this lesson's title, Add and Subtract Mixed Numbers, into your notebooks. Now that we have that, let's look at an example. So again, the first step, just like when we add or subtract just fractions, when we add the mixed numbers, the process is exactly the same with some very minor differences, which is the whole number. However, the whole number will stay consistent, and you'll see that in this example. So you notice how there's a space right here and right here? That tells you the 2 is a whole number and the 3 is a whole number. So first, step 1 is writing it the way that we normally would see it. So that would be the whole number 2 with a fraction of 7/10 plus the whole number 3 and then the fraction of 4/5. Don't forget, we use the / when we are typing it, because most programs do not let you write a fraction form. Some do, and more programs are letting you do that. However, there's a lot of programs that don't, so that's why we need to be able to recognize both. Now, as we would add or subtract just fractions, we have to find the common denominator. This does not affect our whole numbers, because whether it's 10 pieces or 100 pieces, if that's my denominator, my whole number has those pieces. So at first, we need to focus on the fractions. And I noticed this fraction has a denominator of 10, and this one has a denominator of 5. So the very first thing that we need to do is we need to find our common denominator. So as we've done in class, we found a common multiple. So that's a CM, or common multiple. So this denominator is 10 and this one is 5. I always like to put the smaller number on top and then the smaller number on the bottom. You could choose which either way. So as we said in class, to find the common multiple, we would just list the first couple of them. So multiple means 5 times 1, 5 times 2, 5 times 3, and so forth. So 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, and that gives me the first 5, so I'm just going to leave that there. Then I do the first 5 of the 10. 10 times 1 is 10, 10 times 2 is 20, 10 times 3 is 30, 10 times 4 is 40, 10 times 5 is 50. And I list the first couple of them, and I look and I go, okay, I'm going to underline the ones that are common. So 10 is common in both, 20 is common in both, and that's all I've listed so far. So with the common multiples, I could use either 10 or 20. And then I circle the one I'm going to use. And of course, we like to work with smaller numbers, so I'm going to circle the 10. I'm going to use the 10 as my common multiple. Okay, so with that, I list the 2 fractions on the side. And what I do to one, I do to the other. So since I'm making it as 10 times what gives me 10, and that's 1. So I would multiply the denominator and the numerator by 1, which gives me the 7/10. And then the other one, the other fraction, is 4/5. 5 times what gives me 10? Well, I know 5 times 2 gives me 10. Since I multiply the denominator by 2, I need to multiply the numerator by 2. So 4 times 2 is 8. And 5 times 2 is 10. Now that these two multiples are the same, I can then go over back to my original numbers over here and write the equivalents. So my equivalent fraction for 7/10 stayed the same as 7/10. So I'm going to rewrite that as 2 and 7/10. The 4/5, my equivalent there, became 8/10, and my whole number stays the same. So it becomes 3 and 8/10. Now, I didn't change anything because they were whole numbers, so I didn't have to calculate anything with the whole numbers. Now that I have mixed numbers, though, I like to write them vertically, meaning going up and down. You don't have to, but I like to because it shows that we always add from right to left. So I'm going to rewrite 2 and 7/10 on top, plus the 3 and 8/10 on the bottom. This is a plus sign. Just like we would standardize add. Since both my denominators are 10, I could just add the numerator. So 7 plus 8 is 15. So I have 15 over 10. And then I add 2 plus 3 is 5. So my solution is 5 and 15 tenths. But if I look at this and I go, okay, my numerator is larger than my denominator. 10 pieces equals a whole. So if I took 10 pieces out of this, I know that I have another whole. So this is going to equal whole number 5 plus another whole number 1. And since I took 10 pieces out of here, I'm only left with 5 pieces in my numerator. So 5 plus 1 gives me 6. And I have 6 and 5 tenths. And knowing my divisional facts, I know 5 can go into 5 and 5 goes into 10. So I'm going to divide both of them by 5. I'm going to simplify. But my whole number stays the same. So the 6 stays the same. 5 divided by 5 is 1. And 10 divided by 5 is 2. So I know my solution to this one is 6 and 1/2. So again, I wrote the numbers the way that I am comfortable viewing them. I find my common multiple, then my equivalent fraction to have that common multiple as my denominator. I put it in and I add in, or if this was a subtraction, I would subtract. And then I would simplify. And I got the 6 and 1/2. I want you to pause this video now and write in your notebook the problem and all of our work. So as you see, when adding or subtracting fractions is the same thing. So this one was addition. So let's prove that adding and subtracting fractions is the same thing as adding or subtracting mixed numbers. Let's do a subtraction one too. So here we have, again, the space tells me that this 14 and this 5 is a whole number. But I don't like adding that way, so I'm going to rewrite my numbers as the way that I like to write it. And I like to see and work with it, because on the computer, I can't write the fraction in this form. Again, though, I got to be very careful and make sure I keep the space for this subtraction so it doesn't look like that's actually my fraction line. So I look here and I go, okay, now I have them in the way that I like to see them. But my denominator here is 4 and this one is 6. So again, I got to find my common multiples as we've done in class. I could do 4 times 6 or 6 times 4, the opposite as I did in the adding and subtracting dish the fractions. But let's get comfortable with this. So again, my denominators is 4 and 6. So I'm going to write the first 5. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Now, if I needed to write more, I can. But let's just see if this works first. Then I do 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. And 6 times 5 is 30. So I notice I have some common here, so I'm going to underline the ones that are common. So I have 12 is the same. Okay, and that's the only one that is the same, so I'm going to circle those because that's the ones I'm going to use. If I kept going, I would notice that, like, say 24 would work. But let's always use the smallest number because it's easier for us to calculate if we use the smaller number. So now I write the fractions. I have my 3/4 and I have my 3/6, right? Okay, I have that, and write this here because I made a little boo-boo there. Now I want it to be 12. So 4 times what gave me 12? So I know it's 1, 2, 3. So it's 4 times 3. What do I do to the bottom? I do to the top. All right. So 3 times 3 is 9. And 4 times 3 is 12. So equivalent fraction for 3/4 would be 9/12. So now I look here. 6 times what gives me 12? And I know it's 2. What I do to the denominator, I do to the numerator. So 3 times 2 is 6. 6 times 2 is 12. So the equivalent fraction that I'm going to use for 3/6 is 6/12. So now I rewrite them here. So the 3/4 we said was 9/12. Take mine to make a separation for my subtraction. And we said that 3/6 became 6/12. Again, I like to rewrite mine going vertically, right? When I'm adding with whole numbers. So I'm going to rewrite that 14 9/12, subtracting 5 and 6/12. And again, we go from from right to left. The denominators are the same, so now I'm doing 9 minus 6. 9 minus 6 gives me 3. So I have 3 over 12. The reason why I do this first is, say this was 6 and this was 9, I would have to borrow. We'll work with that in class, as that's a little bit more complicated for the video at the moment. Now I look here and I go, 4 minus 5, I can't do. So this 1 becomes a 0, and this 4 becomes a 14. 14 minus 5 gives me 9. And 0 minus 0 is 0, so I could write the 0, or I don't have to write the 0. Now I look at this, and this equals 9 and 3/12. And I notice that my numerator is less than my denominator, so I don't have to simplify in that way. But I realize that 12 can be divided by 3, and so can 3. So I'm going to divide both my numerator and my denominator by 3. Remember, what you do to one, you must do to the other. So 3, the whole number stays the same. 3 divided by 3 gives me 1. And 12 divided by 3 gives me 4. So in fact, I know that the answer to this is 9 and 1/4. So again, I rewrote the number the way that I normally see it. I find my common multiple. I make my common multiple, finding the equivalent fraction with the common multiple as my denominator. Then I substitute, and then I subtract, which is the same way as when we would add or subtract. So now I want you in your notebooks to write down this question and all of this work. And just to make a note of it, if I had, say, 3 expressions, I would do the same thing, except I would find the common multiple of all 3 of them. Okay, so you might have to do that when you get equations like that. So here's the third question. I'm going to pause the video to rewrite it to save some time. And then I'm going to write down the first 5 common multiples. So here I listed my common multiples. Then I figured out my equivalent fractions. And then I inputted my equivalent fractions to where my fractions was. So adding this, I would first add, and then I would subtract, because my order of operations says I do adding and subtracting together from left to right. So the first thing I'm going to do is I'm going to add, and then I'm going to subtract. But to save video time, I'm going to pause the video when I do that. So what I did was I added first to get the 5 and 8/6. I didn't simplify here because I still had to subtract, and I don't want to simplify to have to borrow later on. So in this case, I would have had to do that, and then I would have to find common denominator. So I waited to the very end. After I did the subtracting, then I simplified to find that my answer was 4 2/3. Okay. Again, we would do this step by step. Write it the way that you're used to writing it, finding your common multiple, finding the equivalent fractions with the common multiple as your denominator. Then I added and then subtract because addition comes first, and then I simplified. So I want you to pause this video now and write this in your notebooks. Now that we've done some on our own, I want you to try doing on yours. So here we have 2 different ones. Okay, you have 2 and 5/6 plus the 3 and 1/2. You got to find what that equals. And then this one you have 8 and 2/3 minus the 3 and 2/5. I want you to show all of your work and how you would do this. Okay, again, this is, that kind of looks like 5. So 2/3 minus 3 and 2/5. You may rewatch this video as many times as you need to show this. Make sure you show all of your work so that you can receive full credit, and write down any questions that you have so I can answer it in class.